let's talk about reading commercial blueprints. If you have not seen the residential blueprints video that I did, go make sure that you check that out as well. Very similar kinds of stuff, but residential and commercial are different in that commercial are going to be engineered drawings. So things in commercial are a lot more specific. Typically you have an engineer that's doing a bunch of calculations because there's things with buildings. A lot of businesses tend to have specific type of power that affects the entire power grid. So they have to figure out if they have a lot of inductive loads, a lot of like motor loads and equipment and stuff like that, that can really affect the utility system more than a residential application would, where you've just got like, you know, somebody's got some computer and they've got lights and they're vacuuming and watching a TV. The impact on the utility is not as severe, so it doesn't need to be calculated so dramatically, so specifically for residential. So most of the time in residences, we're dealing with architectural drawings. Some architect is just drawing stuff up, and it's up to you, the electrician, to figure out where everything goes. But with a commercial plan, things are very, very planned down to the T, calculated very severely. So let's break into actually what's inside of one of these. So typically the beginning of a plan is going to have the overview of the whole property, right? We're gonna have like kind of a street view, a block view, so that you know what the whole lot is, and it kind of gives you some extra information, parking, all kinds of stuff like that. And then you're gonna have some general symbols, general notes, general things about the entire job. And then as you flip through, you're gonna go through more details. Again, in the beginning of this, we're talking architectural. So you're gonna see all of these pages are gonna be A1, A2, A10, things like that. So that's just the architectural general information about the structure and the design of the place. The next page, they show, this is a kitchen, so or it's a restaurant, so they're gonna show, you know, the general kitchen area of this whole thing, while there is, you know, some storage and bathrooms and stuff back there. That's not like, this is the main meat and cheese of what's going on. And then the dining room is the other kind of like, you know, main thing that's going on. Restaurants are typically talked about as front of house and back of house. Back of house is always where the food's made and the whole business is run, and then the front of house is where everybody sits. So just kind of a general overview of that. I'm not going to go through every page, but we should have a elevation just like we had on the other ones. Shows the front elevations. We've got a ceiling floor plan. So this is the existing framing plan. So this building already had a whole bunch of ceiling trusses throughout the whole thing, and it shows where all of the walls are. And then it has a elevation, so you can kind of see, you know, this reflected horizontally. Anyway, so this is, you know, that's general. You're going to have a roof plan as well. So the ceiling plan was inside. The roof plan is up on the actual roof, what's going on up there, because there's going to be ducts and air handlers and exhaust fans and all kinds of equipment going up on the roof. So they just give you an overview of that. Then we've got more elevations, so it shows walls, bathrooms, mirrors, sconces, just like we had in the residential. And then we've got an equipment plan. So this is, in this situation, we've got all of this kitchen equipment. This is a restaurant, right? So we've got all kinds of stuff on the cook line. We've got a prep area in the back. We've got a dishwashing section. We've got walk-in cooler, refrigerators, freezers. We got this whole front of house section where people take orders, and there's point of sale. You know, you walk up and give your order. A lot of times there's like little refrigerators and drink stations and salad stations and stuff like that in that area. So this just shows all of the equipment that's being installed so that we know what to wire, so the mechanical contractors know, you know, where they need to put things. Another thing that we've got is a reflected ceiling plan. So this is not actually the lighting plan, but it shows all of the lighting on it. So it shows that there's going to be all these 2x4 LED lights throughout here. There's going to be some 1x4 lights that are going in the back, spotlights. It shows all these little cans and everything. But this is just kind of showing what the ceiling looks like for everybody. There's exhaust, you know, in there, but that's not actually electrical. Again, we're still in the A's. So let's skip through. All right, so that was all of the architectural side of things. Now the rest of the plan is going to be our M.E.P drawings, or our mechanical, electrical, and plumbing drawings. So we've got a general notes and provisions thing. We've got a symbols page, but this is like everything the mechanical contractor needs to know. It's a good thing to be an electrician to read this as well, so that you understand what they have to do. You don't have to go through every single detail, but it's a good idea to understand what they're doing as well. Because the more that you know about all the other trades, the more you're going to be able to like work with them and know what's going where. So you're not like double doing all of the work because you didn't read the plans and you didn't know where something like a duct was going, and they might have some monster duct running through and you put a whole line of cans right above it. So it just helps to know what they're doing so you can go talk to these people. So the mechanical plan, it's all mechanical stuff, right? This is the rooftop, so they know where to put all their ducts and they know where the air handlers are going and where they need to make their penetrations. It's same thing as the electrical. It's going to give them details on what kind of hardware, what kind of mounting they need to do. You know, so this is all going to be inspected. So this is what the mechanical contractor has to follow, just like our plans. You know, we give a plan, we get it submitted, and then we have to wire it to that. And then little things are going to change for sure, but it's just overall, all the big things that we need to know are in here. So anyways, that's mechanical. Then the next is electrical. Same thing on electrical, right? We have a whole plan here, or a whole list of notes, provisions, legend, everything. So this is the general, read through all of this stuff because this is everything you need to know for the job. Typically with electrical drawings, you're gonna start out, well, they're all gonna be different. You're gonna have one page that's lighting. It's not gonna be power, it's not gonna be all your receptacles and all of that stuff. Typically you're gonna have a lighting plan, and then on a different page, you're gonna have a power plan. So in this case, we've got lighting. Shows what they wanted, like specific layouts of switches, switch banks to turn certain things on. When I'm wiring stuff, you can see all these say L3, these say L2, L5. Each one of these numbers corresponds to a specific switch bank or a specific switch, because they have a lighting control system in here. So I just wanted to make it very visually easy to understand that these are all on one switch, and that's the T switch. So I put T as yellow and I highlighted yellow. I'm crazy with highlighters on jobs, and I draw like every red box right here is a junction box that I've got in a ceiling, and I write what panel it's going to, L1, L2. So I just know where all of the junction boxes are because this whole thing is a grid ceiling. So if I need to know, like, oh, there's a junction box, I can't figure out where this is. I think there was a junction box up there. Open up the plan. Oh yeah, I got 3 of them right there. I even wrote the circuit numbers in pencil next to each one, so I already know what circuits are in that box. That's just how I do things. You guys don't have to do that, but that's what I do. Another thing you're gonna see these little circles with a number in them. A lot of places you'll see like one here, 3, 1, 3, 5. If you look over here, circle with a number in them. These are all the notes for the drawings. So a lot of times, instead of just having long, crazy notes or putting just some random little number somewhere that's not going to get seen, they will call it out with a big circle. And so it lets you know, like, hey, if you're curious about this exit sign right here, or this combo, it's an emergency and exit, go to 1. And then you might have something, I don't know, what was 5 over here? It looks like an occupancy sensor call out, maybe. Switch bank. Oh yeah, that was a switch bank location. So they wanted to hide the switches so customers didn't have access to them. So there's this back storage area that they wanted to put all of these lighting control switch banks in. So they just said this is the location of the switch bank. And then there's another one. 5 actually has 2 call outs for that same one note. So there's a switch bank location for one of them and the switch bank for the other one. So anyways, you have the lighting plan. These are all one kind of light. They're 2x4s, these are 1x4s, and these are all cans. Or they're not really cans, they were like kind of little mono points. But that's the lighting. Next page is power. So we're still within E's. Now you notice there's no lighting on here at all. This is just call outs for equipment. So with this specific job, I remember this was years ago, but what they did is they had a separate sheet that came with the plan that was just an addendum to the plan, and it listed like E1, E2, E3, E4, E5, all of the equipment that was going into this kitchen. So we knew exactly what model numbers, dimensions, how much power it took, everything. So all of these little call outs, they're similar to notes, but you can see they're not over here. But like E64, right? There's so many that they had to create a separate page just for that, but it wasn't actually part of the plan because it's just a schedule of equipment, and equipment often changes. Another thing you'll notice is that you've got all these L1-43, L1-45, well, a lot of these are hand drawn, L1-53, L1-51. Those are circuit numbers and panel numbers. L1 means panel L1. So I've got 3 panels over here. I've got L1A, L1B, and L2. So it lets me know this is from panel L1, circuit 43. So I've got 4 panels that are going on the inside of this restaurant. So I need to know where I'm wiring things to. So that's what all of that's about. I like to, again, highlight. Typically I'll do color. So anything that's panel L3, I'm gonna do all of the home runs in that color. Just makes it easier to identify things when you're going through it. You'll notice too, on the home runs that are marked by the architect or by the engineer, they have these little lines on them, and it's just telling you that's a hot, neutral, and a ground. That's what those lines mean. So all of their home runs that they draw, they're gonna do that. Like this one right here is 3-phase. So you've got 1, 2, 3, 4, and 3 little ones. So you've got 3 different phases, neutral and grounds for each phase. And then when I draw mine, you know, I do it a little bit different. Like 2 lets me know that it's gonna be 220, stuff like that. But that is your power plan. It's gonna show receptacles, all your home runs. Sometimes it'll have equipment if it's a situation like this where there's lots of equipment. Now we have a roof plan as well. So it says rooftop, but we're in electrical. This lets me know what all of the HVAC equipment is. We've got little exhaust fans up on the roof. So in the kitchen and bathrooms and stuff, we have to, you know, have air that leaves. So we have all of these pieces of equipment, and it shows what circuit numbers, what panels everything comes from. It shows that you need a GFI circuit up there to service the equipment. So it's the electrical version of the HVAC equipment plan. And then we have a lighting control panel schedule. This you might not have on your job, but with this, I said we have lighting control system. So it shows what circuits are specifically designated for the lighting control system. And then I have a light fixture schedule. Another thing you're gonna have on jobs is all of your light fixtures are gonna be planned out ahead of time. So they already know, you know, from Acuity Lighting, 120 volt recessed can, it's a 4-inch LED downlight. So if you're ever wondering like what size cans are getting put in here, if you're in a commercial environment, you're probably gonna have a light fixture schedule, so you can answer that question on your own, just flip through. And then on the actual lighting plan, it'll say like L1 next to it or within the light or something like that. It'll say L1, L2, L5, not panel L1 and L2. Don't get confused on this. It'll just say L1, or it might say like A2, something like that. But it shows you this, that's the call out so that you can look at this light fixture schedule and figure out what lights go where. Okay, so on commercial plans, we've got the service. Notice on the residential, we didn't have any of that. That's not planned for. Services are planned for by engineers in commercial. So we have a riser diagram. Some people call it a one-line diagram. But a one-line diagram is going to show you how everything is wired at the service. It doesn't necessarily have to look exactly like this, but the series or the order in which things are done has to be called out. So this will actually, this is the service grounding detail. So this shows you how they want everything grounded, all connected, you know, from this CT, and it even shows you what size grounds you need to run. Now, it may be wrong for code, but the engineer drew it. So if you follow what they did, they take the liability on for that because it's drawn it's wired to spec. If something's not right, then you need to get a hold of the engineers and say, hey, this isn't right. Or they might say, yeah, but we derated and we have our own way of doing things and we still stand behind it, and you can still do it that way. But a lot of times code and engineering is a little bit off. If something's like way off, You know, like you have way too small a wire on here for what's actually being installed. Like that's something you need to make a call or let the builder know, and just be like, I don't feel comfortable running what they said. I think it's just a misprint. I think you typed something up. Engineers are wrong a lot. You know, like they're great. Engineers are awesome. You know, they're smart. They're also human and they mess up. So you're going to come across drawings that are not right. So we've got the riser diagram, but it'll show this is where the meter's going. They're going to have a CT enclosure, which just means that they're going to have little donuts inside of there, and each hot that's coming into the building from the riser is going to be metered because the wires are probably so big that you can't fit them inside of an actual meter. So there's low voltage wires that go to those donuts, and the meter just uses low voltage wires to detect how much current is flowing through each one of those conductors through the donuts. So the CTs all go in a CT enclosure that goes down to a wireway. Some people call these gutters, auxiliary gutters, but just some kind of way to run the wire, a wireway. And then from then you're tapping out for, what does note 4 say? A new 240 volt, 225 amp panel. Number 5 is 240 volt, 225 amp 3-pole. So you've got a single phase and a 3-phase. And then it shows, you know, like how these should go up into the building or, you know, go across to these other panels. So from this number 5 panel, we're going to be going up and running to a new L2 panel. And then from the other number 4 panel, from this new 225 amp single phase, we're going to be running up and over to L1, which is a 2-section panel. It's really interesting. There's section 1, section 2, which essentially just means it's one monster panel. But because there's so many circuits, they don't make a panel big enough. So they're going to have 2 panels side by side that are just wired into one. They connect it to the other one. So it's essentially, if you just flipped them, they would be one like massive panel. So that's what a 2-section panel is. It's just 2 different panels that are the same panel. From one of those, you can see another wire or another conduit goes up and goes and feeds panel 3. So panel 2 is isolated. Panel L1 has L3 coming out of it. So that's how you can read where's the main power coming from and how is all of the electrical system actually working. Now, one other thing that's really helpful to note is all of these conduits that you see, there's little notes. This says 3 number 2s and a number 6 copper G or ground. And it says 1 1/4 inch C, which means in a 1 1/4 inch conduit. Another example over here, it shows what the actual riser is. It says 2 sets of 4 3/0 conductors. That means there's going to be 4 of them. They're 3/0, and there's 2 sets of those, so they're parallel feeding. And it says 2-inch conduit. Then tail 5 foot minimum at weatherhead. So they're saying just like leave 5 feet at the weatherhead so that they have something to work with. But yeah, so it gives you every bit of detail that you need to know about the service, really. So that's your 1-line diagram. And then the last page that you're going to have, this is 601. This is your panel schedule. So we have a lot of different panels going on here. We've got our L1 Section 1, L1 Section 2. It gives you information about the actual panel. It's a 225 amp MLO, which means it's main lug. There's not a main breaker. It says it's voltage 120, 240. It's a single phase 3-wire panel, meaning hot, neutral, 3-wire. It shows that it's a 225 amp bus or 225 amp panel. So what I do, you don't have to do this, but it just makes it easier for me and my dummy helpers. I put red, black, red, black, red, black. You'll notice red starts first. City of Austin always does red on the left. It's just different than the rest of the NEC. But to make it easier visually to understand, I just, on my 1-lines, I do it on all of these too. So you can see single phase, right? There's no blue in any of that, but there's blue here. So this is my 1 3-phase panel. Anytime I make changes, I take white out and like actually rewrite stuff in there because a lot of times things do change. But yeah, that's it. Panel L3, panel L2. This is a 225. This is a 100 amp panel. This is a 225. This is a 225. So if you ever get a bunch of equipment too and you're like, oh crap, I don't know which one was L2 out of all of these enclosures sitting here, you can just come over and look, be like, oh, L3s are 100 amp. So that's going to be that tiny one right there. It's just, that's how you might see journeymen know where things are going really quickly. And you're like, how do you just know that? It's because we've had to look at all of this stuff, right? We have had to look through these plans so many times and talk about and think where things are going. So we have to remember what's single phase and what's 3-phase. So we just have all of this information at our disposal, and we're flipping through this thing all the time. So as a helper, I recommend that you do the same thing. Start to really pay attention to what's going on in the plans. I wouldn't be sitting here while everybody's working, and you should be working and wiring stuff, just like sitting here looking at the plan. But if you're a journeyman and you got 10 people on a job site, I would be sitting here looking at the plan, because you should be running the other 9 people on that job site and making sure that everybody else has stuff that they're doing. And at that point, you're just keeping the train going. So you need to really pour over this thing in detail to make sure that you have a plan for everybody and that you're executing that plan how it should go. So if you're ever just on a job and you see a journeyman just staring at a plan for like hours, it might be because the job's really crazy and they need to understand all of the details. And then when you got 15 people coming up and asking you all these questions, you don't have enough time to work anyways. So knowing the plan very, very well is really important. And then anyways, I'm not going to go in depth. Plumbing, pretty much the same thing as mechanical. It's just plumbing, right? Same layout, same information, just lets them know everything. And then you might have handicap accessibility stuff. This was actually something at the very beginning that I didn't show, but this has stuff about hinges, doors, openings, like doorways. It has, what all of the handicap rules are for things. So there's ADA compliance and a lot of things. This is commercial, so this definitely has to have ADA involved. So it has to be accessible for somebody in a wheelchair or anybody that's got mobility issues. All right, so that is it for commercial plans. Again, if you have not seen the residential video, make sure that you go check out the residential video. Very similar kind of things, but there's a lot of differences to consider as well. Thanks for watching. I love you crazy people. I'll see you in the next one.